Good day, students. You are welcome to another episode of our lecture video. Today, we'll be discussing about preliminary tests for lipids. Introduction. So, what are lipids? Let's first understand what lipids are. Lipids are heterogeneous group of water-insoluble organic molecules that can be extracted from tissue using non-polar solvents. So lipids on their own, they are insoluble in water. They cannot be solubilized by water, but rather non-polar solvents can actually dissolve them. Non-polar solvents include chloroform, ethyl ether, benzene, and so on. So during this practical, you will be carrying out techniques that are used by analysts to investigate the nature of free fatty acids that are present in lipid sample. So you know lipids are classified into three categories. We have the simple lipids, which they are called neutral lipids. We have the complex lipids, and we have the derived lipids. So in today's class, we'll be discussing, because our practical is on the simple lipids, so we'll be discussing about the simple lipids. So fats and oil, which are examples of simple lipids, they are made up of triacylglycerols, and the fatty acid composition can be saturated or unsaturated. You remember triacylglycerols, they have glycerol backbone with 3 fatty acids attached in esterification reaction in ester linkage. So the fatty acid composition can be either saturated, those that have single bond in their hydrocarbon chain, or unsaturated, those that have multiple double bonds in their hydrocarbon chain. And we can have example of saturated fatty acid. You remember we have myristic acid, 14 carbon, palmitic 16, stearic 18 carbon. They are all saturated. And for the unsaturated, we have oleic acid, 18 carbon, 1 unsaturation, 1 double bond. Linoleic acid, 18 carbon, 2 double bond. Linolenic acid, 18 carbon, 3 double bond, and so on. So we have some series of tests that can be used to check for the purity of a fatty acid. We have iodine number, we have saponification number, Richard-Missel number, and acid. We have acid or neutralization number, or you call it acid value. So for the purpose of this experiment, we are going to be concentrating on the acid or neutralization number or acid value. So in this experiment, it is divided into 3 phases or stages. We have tests for the presence of double bond, and under this, we have samples like oleic acid, palmitic acid. We have fresh lipids and exposed lipids. So here you will be given these samples, and you are going to carry out the test on each of these samples, and you are going to be reporting it as test, observation, and inference. So under test, the samples and the reagent that you have added, maybe 1 ml of your test sample, let's say oleic acid, plus the reagent, and what did you observe, how many number of drops of the reagent that is required to produce the color that you are going to see, and also the inference. What do you have? We are testing, remember, you are testing for the presence of double bond. Are there double bonds or no? So you check and you record it as test, observation, inference. So for the second stage, you are going to do test for the free fatty acid. So here, what you are interested in, you want to check to see whether the lipid is intact, or if the lipid has some free acid, fatty acid liberated. So under this, we will be talking about what we call rancidity, because some fats that are stored inappropriately, they undergo what we call rancidity, and this rancidity is the deterioration of fats and oil that is resulting in unpleasant taste. And this rancidity actually liberates free fatty acid, and the amount of free fatty acid that are present gives an indication of the age and quality of that particular fat. So for lipids or fats that is stored properly, it should not undergo what we call the rancidity. So, and what causes this rancidity? When you have exposure of fats and oil to air, moisture, light, or microorganisms. So you need to keep your fat uh, appropriately in a proper condition, okay, so as to prevent rancidity. So when it is exposed to air, moisture, or light, it can undergo, or microorganism, it can undergo rancidity. And this rancidity is divided into two. We have hydrolytic rancidity, which is as a result of partial hydrolysis of triacylglycerols by the bacterial enzymes, and oxidative rancidity is due to the oxidation of unsaturated fatty acids. Okay, now here also you will be given your samples. Here you will be testing on the samples that you will be provided with. You will test and you will have your observation, and you have the inference to derive from that. So here, under this would be the last segment, or the last stage of this experiment, is determination of acid value of a fat. So here you are going to let's first define what acid value is. We say it is the milligram of potassium hydroxide that is required to neutralize free fatty acid that is present in 1 gram of fat. So here you are going to weigh accurately 2 grams of the test sample, and you suspend it in fat solution about I suspended in fat solvent, which is chloroform, in about 10 ml of it, and you add 1 ml of phenolphthalein, and you mix thoroughly. Then you titrate with 0.1 molar potassium hydroxide until you have faint pink color that persists for 30 seconds. You are going to record the number of mils of potassium hydroxide, and you calculate the acid value. So you record the titer value, and you calculate the acid value, and molecular weight here that is given for potassium hydroxide is 56, and you have 0.1 molar of potassium hydroxide contains 5.6 gram per liter, or 5.6 milligram 5.6 milligram per mil. So you have samples here, fresh and exposed lipids, and in the calculation you are going to carry out the calculation for both acid value for both fresh lipid and exposed lipid. So assuming for fresh lipid you have the titer value as 22.5 mils, and you remember that 1 mil of potassium hydroxide consists of 5.6 milligrams. So 1 mil of potassium hydroxide is equals to 5.6 milligram. So your titer value, which is 22.5 for the fresh, will be equals to X. Now X will be 5.6 times 22.5 divided by 1, which is 126 milligram. But 1 gram of the lipid sample was used. Initially, you have weighed out, sorry, 2 grams of the lipid samples was used. You remember initially you weigh out 2 grams, right? So this titer value that you have gotten, this assumed titer value, is for the neutralization of the 2 grams. So you need to divide by 2 to get your acid value. Remember, acid value is in 1 gram of the fat, free fatty acid that is present in 1 gram of your fat. So you got, let's say you have 63 milligram here. So this will be your acid value for the fresh lipid. So I will leave this as exercise for you, and I will assume that by now you must have carried out the experiment so that you can calculate the acid value for the exposed lipid, and you can deduce the differences between the two acid value. So, and what can you say? Which one has higher acid value and which one has lower acid value? And if a lipid sample has a low high acid value. What does that mean? What does it mean if it has higher acid value? So you think about that. And this brings us to the end of this lecture video. Thank you for listening. See you next. Bye bye.